Okay, we are going to write an equation of a line tangent to the curve described by this parametric equation when t is equal to 1. So remember, we have to have the slope first, right? Slope, point, and then the point-slope form for the equation of a line. And then the slope in our situation, it will be the derivative. And remember, the derivative in our situation is going to be dy dx, all right? So let's go ahead and do that first. Let me write down m for the slope, and once again, we need to get dy dx. However, in the parametric equation situation, dy dx is the same as dy dt and then divided by dx dt. Okay? And then let's go ahead for the dy dt. We look at the y equation and do the usual derivative. Differentiate y with respect to t. Derivative of 3t minus 2, just 3, isn't it? So we have 3 on the top, over. And for dx dt, we differentiate x with respect to t. Derivative of t squared is going to be 2t. And then derivative of plus 4t is going to be plus 4. And the derivative of 1 is 0. So yeah. All right, so this is pretty much the expression that we need. Anyway, we plug in t is equal to 1. And this is the notation indicating that I'm going to plug in t is equal to 1 into here. So that means I will get 3 over 2 times 1 and then plus 4. On the top is 3, on the bottom is 6. Overall is 1/2. Okay, so that's the slope. And then we need to have the point. Point is x comma y, right? So for x, let me just write this down. When t is equal to 1, x will be, so let's look at, we have 1 squared plus 4 times 1 plus 1. 1 squared is 1 plus 4 times 1 is 4. 1 plus 4 is 5 plus another 1 is 6. And then for the y, this is going to be 3 times t, which is 1, and then minus 2. 3 times 1 is 3, minus 2 is 1. So 6 comma 1, right? So if you would like, here is the point, 6 comma 1. Okay, so equation of the line. Let me use the point slope form first because we're the point and then the slope, right? So that means it's going to be y minus y1, which is equal to m times x minus x1. Okay, so this is my x1, this is my y1, and this is my m. Okay, y minus y1 is 1, and then the m is 1/2. Parentheses, just the parentheses, x is still the x in black, and then minus for the x1 is 6, right? And this is y minus 1 equals to distribute 1/2 x, 1/2 times -6 is -3. And then add a 1 on both sides, cancel. The good old days, right? Y equals to 1/2 x, and then this is going to be minus 2. The good old days to find the equation of a line. And this is it. This is the equation of the tangent line.